So let's try to come up with a simpler example. Let's say that I have a sample space that is divided into 3 events, A, B, and C, where the and let's see, where the intersections of these are all um, the null set. So this is a partition. Okay, and let's see if we can figure out the following. What is, let's say we have some event E, and we know the following. We know that the probability of E given A equals 1/6. The probability of E given B equals 1/3. And the probability of E given C equals 1/2. And the probability of A equals, let's say this equals 1/3, equals the probability of B equals the probability of C. Okay, so now tell me, what is the probability of E? So if you're doing this by listening to the recording, pause the recording here and figure this out. Then I'll continue in a moment with my solution to this problem. Go back. Okay, well, let me sort of show you what I would do. You're just applying the law of total probability. So this is the probability that E occurs, given that A occurs, probability of A, plus the probability that E occurs, given that B occurs, times the probability of B, plus the probability that E occurs, given that C occurs, times the probability of C. Well, I've given you all of these. This would be 1/6 times 1/3 plus 1/3 times 1/3 plus 1/2 times 1/3. Now, oh, not 1/6, 1/3. Now you could sort of struggle with the fractions in more or less simple ways. And the simple way to do it is to factor out the 1/3. So this would be 1/6 plus 1/3 plus 1/2 times 1/3. And then I could put these all over a common denominator, 1/6 plus 2/6 plus 3/6 times 1/3, which equals, well, 3, 4, 5, 6, which equals 6/6 times 1/3. So that's just going to be 1/3. Let me draw a picture of what this might look like. Here's my sample space. I have to divide it up into 3 equal size segments, equal size events A, B, and C. And now if the probability of E, given that you're in C, is 1/2, that means that E has to be here in blue, is to be 1/2. But then in B, let's see, in B, it's 1/3. So given that it's B, that you're down at the level of 1/3, but then down over here, this is 1/6, because the overlap of A, given A, the probability that E occurs is 1/6. So this is blue is E. So you can see that from the area here of the total area, you've got one anyway. So this is sort of a picture of how E is occurring, and that you end up with 1/3 of the essentially this is, if you divide it up into 6, this is like 2 6 and 3 6, so that you can take one of the 1 6 and board over here. You can sort of even it out, so it's about 1/3 all the way through. Okay, well this sort of gives you a picture of what's going on with this, and how this problem just involves knowing the law of total probability and sort of sorting, putting putting the pieces of information I give you together. Let's do another problem of this type. Let's say where I give you that S equals A union B, and this is a partition, and that the probability of you have some event E, and that the probability of E equals say 1/2, and that the probability of E given A equals say 1/6, and the probability of E given B equals let's say 1/3, and the probability of B equals let's say 2/3, then what is the probability of A? Okay, I'll pause the recording. Okay, so to find this, what we would do is we just write down the law of total probability for we have the information for dividing it up this way. The probability of E given A times the probability of A plus the probability of E given B times the probability of B. Well, let's see what we have. We have a 1/2 here from this. The probability of E given A is 1/6. This is what we want to find. This is our sort of like probability of A plus the probability of E given B. Well, that's 1/3 times the probability of B, which is 2/3. So I've given you all the information except for one variable, and so I can have to mess with the fractions here of maybe putting say subtract. Let's simplify it a little. We can see here that we have over 3 times 3 is 9. And so it's going to be a little bit of awkward with the fractions, but let's take this fraction is 2/9. So we're going to have 1/2 minus 2/9 equals 1/6 probability of A. So putting the right-hand side in the left, we'll get 1/6 probability of A equals 1/2 minus 2/9. And then we can multiply both sides by 6 to get probability of A equals 6 times 1/2 minus 2/9, which is hopefully going to be, this looks like it will be well, let's see if we've made sense of this. This is 2 times this. We have to make this a common denominator of 2 times 9 is 2 9s is 18 minus 4/18 And hopefully, sometimes if I just choose numbers here, I can sometimes make a problem that doesn't make any sense. So there's a chance this, I think, unless I've made an arithmetic error, this looks like minus 2/18. And so there's because it's 2 minus 4 is 2. And that means that something has gone amiss, right? Unless I've made a mistake here. Let's see. Because anyway, I'll try to figure out if I just choose numbers here, it looks like I'm getting, let's see, 1/2 minus, did I do, yes. 2/3, 1/3 is 2/9, 1/2 minus 2/9, and then 1/6 equals, yes, it looks like, because this one is obviously coming out to be a negative number. So this is a broken problem because I messed up with the, because I'm getting here a number that is less than 0, because I've got this negative sign. So that means that my probabilities were not a good probability model. And that arose because I just chose numbers. You can't just freely choose numbers here. And I did, and chose them badly. So this one is a broken, but anyway, it sort of illustrates the strategy of what you would do. I have to, usually on concept checks, I go through and create these problems with more precision. So you won't encounter this, hopefully, on a concept check. Well, since it's, let me pause this, stop